What would you see if you fell into Uranus? You know, that BBW, big blue world? It's a gas giant, more specifically an ice giant, but what does that even mean? Because it looks pretty damn solid from up here. Hint, it sure ain't gonna look like that.
Today we're looking at TikToks that make you question everything about the universe.
This similarity is crazy, ready? This is planets orbiting the sun, and I sped it up to show you how similar it is to this, the atom. Maybe our universe is just an atom.
Thank you to all the channel members for support. Our last video did pretty good, so in this video, there's no like goal. If you see it, just like it. Maybe we can get to like 5,000 likes, who knows? Because I feel like sometimes when I be like 3K like goal, it kind of maybe holds me back. So if you see this video, like the video. As y'all know, we're on our road to 100,000 subs, so if you haven't subbed yet, make sure to subscribe. Let's go.
What would you see if you fell into Uranus? You know, that BBW, big blue world? It's a gas giant, more specifically an ice giant, but what does that even mean? Because it looks pretty damn solid from up here. Hint, it sure ain't gonna look like that. So after about 10 years of space travel, you approach the planet with your special indestructible suit that can survive anything. You pass by the rings, which, yes, Uranus does have rings, which go around it like this because of its 98-degree tilt, making it look like it's on its side. But these rings' density is so low that you might not even see anything when passing through it. Scattered matter, too far away to even see when you're inside it, kind of like walking through a fog. Then you enter the upper atmosphere and fall through clouds of hydrogen sulfide, which smells like rotten eggs, helium, and frozen methane gas. This methane gas is actually what gives the planet its blue-green tint, as it absorbs red light and reflects blue. Uranus is also the coldest planet in our solar system, with an average of negative 224 degrees Celsius, so it's about to go down real low. You continue to fall and break out of that first layer of gas and hear the sound of lightning below as you enter the second layer, liquid clouds. We're at about 25 times Earth's atmospheric pressure at this point, and the winds here are blowing around 900 kilometers an hour. So yeah, it kind of sucks. Surrounded by lightning and covered in methane rain, you continue to fall until you break through the bottom layer and see an ocean. Except this isn't the sea level ocean you'd find on Earth. This is Uranus's mantle, which on Earth, the mantle is scorching hot and about 70 kilometers beneath the surface. But instead of molten rock, Uranus's mantle is a dense fluid made of ammonia, methane, and even water. You continue to fall through the fluid, just slower, as the immense pressure here would cause carbon atoms to turn into diamonds. The heat and pressure at this point would pretty much instantly destroy anything, so good thing our suit is indestructible. After literal weeks of falling through thick diamond-enriched fluid 2,000 times deeper than the Pacific Ocean, we hit the bottom. This is the rocky core of the planet, made of iron and magnesium silicate, sitting at 5,000 degrees Celsius, and is the closest we'd ever get to stopping after falling into Uranus.
I remember talking to someone the other day and they were like, it's pronounced Uranus and not Uranus. And I was just like, facts. I don't know why everyone always be pronouncing it Uranus. I feel like the people that really do that, it's just trolls. They're just trying to joke.
Imagine stepping onto Saturn. You take a step and suddenly you're falling endlessly. No ground, no solid surface, just an infinite plunge into a swirling abyss. So what would really happen if you tried to walk on Saturn? It may look like a giant marble floating in space, but it's nothing like Earth. Saturn is a gas giant made almost entirely of hydrogen and helium, meaning there's no land to stand on, only thick swirling clouds that go deeper than you can imagine. If you tried to land, you'd drop straight through violent storms, with winds stronger than the most powerful hurricanes Earth has ever known. The deeper you fall, the darker and more chaotic it becomes. The pressure would skyrocket, crushing anything in its path long before it gets close to the core. Eventually, the gas compresses into a strange metallic liquid, an alien ocean with no surface. And if you somehow made it near the core, you'd face temperatures hotter than the surface of the sun. So if you could explore any planet safely, which one would you pick, and how far would you dare to go?
This is so crazy, but this is Earth, right? This is Jupiter. And this is Saturn and its rings. Just think about it. Look how massive this thing is versus Earth. Earth is so tiny, yet it takes days for us to fly from one corner of the world into another. Imagine that. Imagine if Earth was that size.
That is truly crazy. The size difference is always so like unimaginable, because it's like, because you hear all these references that say like 50 Earths can fit in one Uranus or something like that, and you're just like, okay, but then you see the actual difference demonstrated like that and you're just like, that's a crazy difference.
If you fell into a black hole, the gravitational pull would stretch you out in a process called spaghettification. As you get closer, the gravity at your feet would be much stronger than at your head, pulling you longer and thinner. Eventually, you'd pass the event horizon. At this point, time would appear to slow down for an outside observer, but for you, time might seem to speed up. Finally, you'd be crushed by the immense gravity, merging with the singularity at the black hole's center, lost forever in its depths.
I feel like someone in this world of 8 billion people has a dream to have death by black hole. So the Earth just becomes the sun?
The universe doesn't have a center or an edge. It's not expanding from any particular point, and the Big Bang didn't happen at a specific location. The center of the universe is everywhere. The universe is expanding from everywhere, and the Big Bang happened everywhere. According to the cosmological principle, the universe on the largest scales is homogeneous and isotropic. A fancy way of saying that it looks the same in every direction from all locations. Take any sufficiently large chunk of the universe and it looks pretty much identical to any other. Look in any direction from anywhere and you'll see roughly the same thing. On the grandest cosmic scales, there are no special places or directions that are distinguishable from any other. All cosmic vantage points are equal, and that has profound implications. It means that
they say that this is the scariest space photo ever taken, and I don't think you really understand just how insane this is. This is a picture of Bruce McCandless, the very first human ever to do an untethered spacewalk. He went 100 meters, or about 330 feet, away from his space shuttle without anything connecting him to it. 290 kilometers off of the surface of Earth, surrounded by nothing but trillions of miles of empty space. The purpose of this was to test the manned maneuvering unit, essentially a space jetpack, and lucky for him, it worked, and he was able to make it back to the Challenger. When asked about the experience, he said that it was so cold that his teeth were chattering and he was shivering, but he felt a mix of personal elation and professional pride. Here's another picture of him getting ready to float away. It's been 40 years since this picture was taken, and it's still one of NASA's most iconic photographs, and the perfect symbol of human exploration and innovation.
Why are you guys exploring Mars? What are you going to find there? We don't know. That's why we're going.
Wait. That's not fair. Wait. No, there are two kinds of exploration. One of them is, I have no idea what I'm looking for, but maybe I'll find it when I see it.
Okay.
Another kind of exploration.
You can't argue with him. I've learned it.
Another kind of exploration is, we think we know what's going on, and we want to test our hypotheses. That's another kind of exploration. And one of them is there life somewhere else? We know there's life in at least one place in the universe, and that's called Earth. So what I want to do is go to the frozen surface of Jupiter's moon Europa, cut a hole, go ice fishing down there, put a submersible, see if something swims up to the camera and licks the lens. That's what I want to look for.
Yeah.
Look for life.
Life. But Neil, you were looking for something. When was the last time you just went, I hope to discover something? No, you're always looking for something.
No, but whenever we
Let's talk about how f***ed up the universe is for a second. So we know that the universe is 13.8 billion years old, but what you might not know is that if any number of things had been different, it might not have been possible for either the stars or planets to form. What are the odds of that happening? We'll never know. Now, imagine what the odds are for a planet like Earth to end up where it did, in the perfect spot to sustain life, and then to receive the gift of water from asteroids deep out in space. And then somehow, in that water, which was the perfect distance from our sun, these organisms got their first kick of life. And for over 4 billion years, life defied every single odd and found a way to survive. And there is now a 4 billion year old unbroken chain of life that leads directly to you. Now, ignoring all of that, did you know that the odds of your parents meeting were about 1 in 20,000, but then another 1 in 2,000 for them to stay together long enough to actually have kids? And in the odds of reproduction, there was about a 1 in 400 quadrillion chance that kid was actually going to be you. Now, not only did you defy those odds, but so did your parents and your grandparents and every single ancestor that you have ever had. And I think that makes you pretty cool.
Here are some Mandela effects that will make you question your own universe. And these aren't the ones that everyone talks about, this is some trippy shit. First up, we have the living reincarnation of Thanos' chin. Our beloved E.T. Now, we all know the quote is E.T. phone home. Adorable and classic. Now, what if I told you that that was wrong? And that the actual line is E.T. home phone? It doesn't even make sense. Next, we all know the classic Walt Disney Pictures, shooting star thing. Now, I bet we all remember when Tinkerbell was in the intro painting the dot on the eye. Now, what if I told you this never happened? She was never in it was never a thing. What? Next up, we all know the Three Little Pigs rhyme, ending with the classic, I'll huff and I'll puff and I'll blow your house down. Well, apparently that's wrong, and the quote is actually, I'll huff and I'll puff and I'll blow your house in. In? Eh? Now, from the hundreds, if not thousands, emojis that we have on our phone, everyone remembers the classic robber being on their phones, but this was never a thing. It was never an emoji. You guys want a part 2? Because I got more. Elon! Here are some Mandela effects that will make you question your own universe, part 2. These aren't the ones that everyone talks about, this is some trippy shit. First up, we've got the location of New Zealand. I know, eh? Most people remember New Zealand being northeast of Australia, as shown here. And I'll be honest, when I saw this, I was like, what the f***? But now people are claiming they don't remember it being southeast of Australia. I'll be honest, I don't know what to make of this one, but I will be honest, when I first saw it, I was a little feckin' shocked. I mean, even The Simpsons have it being northeast. Next up, we've got traffic lights. How could this possibly be a Mandela effect? As we know, all fucking traffic lights look like this. Green on the bottom, amber, and then red on the top. However, a lot of people are saying they always remember it being red on the bottom, amber, and then green on the top. Do you ever remember it being this? Next up, we've got sketches. A lot of people remember it being spelt with a T, but apparently that was never the case. And you'll never guess it, another emoji is fecked off. This time, people swear by that they remember hiker emoji. And I'll be honest, me too! It wasn't this exactly, but it was very similar, but apparently Apple never removed it because it was never a thing. What? Elon!
So I literally just woke up this morning and then I saw this in the sky. Is that the moon? It looks like it's getting closer. Okay. That is way too big.
Did you feel that? You can feel it.
We interrupt your regular programming with breaking news of a once-in-a-lifetime event that has left the world in awe and disbelief. Our own celestial neighbor, the moon, is falling from the sky. It's a sight that few could have ever imagined, but one that we are witnessing in real time. Scientists and astronomers are struggling to explain this phenomenon. Initial reports suggest that a sudden and unexplained shift in the moon's orbit may be responsible. Experts from around the globe are gathering data, analyzing the situation, and trying to predict what the future holds.
I guess that's what they're saying it's gonna look like when the moon, if the moon ever crashes into the earth.
But I don't wanna live that way, reading into every word you say, smoking weed with you in the leaves in the fall, in the yard with your dog to the winter gate. I smoke with you, 'cause you taught me to pass the time in your living room. Now
I have a theory. What if life as we know it is one giant loop? As you see in a video, is of it zooming out from the Earth into the universe and the galaxies and everything like that. And we know that the smallest particle is an atom. So what if when you're zooming out, you're really zooming in? Because you're just one big, large body, but when you break you down to your cells on a molecular level, you just get this reality again. Look at this video. Like, isn't that what it looks like when they show the body? Like, look, watch this next part when they get out of, look at that. Nerves. Does that not look like nerves? How is that our universe? It is us. We are the universe, literally.
That's crazy that she said that, because that's exactly what I was thinking about while watching the first video before she showed the second video. Because when you really zoom out, it does look like brain neurons. It look like what if we're just in someone's head?
So what you're looking at here is a computer simulation of absolutely nothing. This is empty space, literally empty space with nothing in it. This is the simplest thing you could possibly imagine in the universe. And you can see it's an interesting place to be, empty space. It's not dull and boring. What you're looking at here is that even when the particles are taken out, the field still exists. The field is there. But what's more, the field is governed by the rules of quantum mechanics. And there's a principle in quantum mechanics, which is called the Heisenberg uncertainty principle, which says you're not allowed to sit still. And the field has to obey this. So even when there's nothing else there, the field is constantly bubbling and fluctuating in what's, quite honestly, a very complicated way. Okay? These are things that we call quantum vacuum fluctuations. But this is what nothingness looks like from the perspective of our current theories of.
Please explain dark matter like I'm a moron. In brackets, I am. It's really easy to explain, actually. Dark matter, when we look out into the universe, we see lots of things. For example, the speed that galaxies rotate, or the way that galaxies interact together, or actually the oldest light in the universe called the cosmic microwave background and patterns in it, which are suggestive of there being some kind of particle. So that's like this stuff, like electrons and things, but some kind of particle that's quite heavy and does not interact with light. So that's why it's called dark matter. You can't see it because it doesn't interact with photons, but it dominates the universe, 5 times as much of it as there is of this stuff, out of which everything we can see is made. So that's what dark matter, the best theory for it. We see it by its gravitational interaction. However, it's not shown, it's not proven that's the case because we haven't detected the particle. And there are experiments everywhere in underground labs and so on, at Large Hadron Collider at CERN, where we're looking for these things, but we haven't seen them. And so that leaves open the possibility that there's something else going on that we don't understand.
What terrifies you the most, an eternal universe or a finite universe?
We say the universe began 13.8 billion years ago because we can measure the speed that all the galaxies are flying away from us. So you can run time backwards, if you like, so to find out when they were all on top of each other. So we say the universe began 13.8 billion years ago. All we know really was the universe was very hot and very dense at that time. We have some theories that the universe was in existence before that. And that means that actually the universe could have always been there, eternal. Some people get upset about that. Some people would rather it had a beginning. The idea that it might have been around forever is more frightening somehow than the fact that it began.
This similarity is crazy, ready? This is planets orbiting the sun, and I sped it up to show you how similar it is to this, the atom. Maybe our universe is just an atom.
I know that video was short, but that's low-key like a lot to think about because I didn't even notice that. Our own freaking planet literally circles like atoms, like electrons around a neutron. That's crazy.
Is the universe a brain? An astrophysicist and a neurosurgeon compared the network of neurons in the human brain to the cosmic network of galaxies in the universe, and there were some weird similarities. The human brain functions with about 69 billion neurons. The observable universe is comprised with a cosmic web of around 100 billion galaxies. In a brain, 30% of its mass is neurons. In a universe, 30% of the mass is galaxies. In both systems, galaxies and neurons arrange themselves in long filaments. Both systems, 70% of the energy plays a passive role. Water in the brain, dark energy in the universe.
So what caused the Big Bang? What was before the Big Bang? In this video, I'll make it simple and quick for you guys to understand. The Big Bang is the stretching of space and time itself. The fabric of the universe that we live in is stretching apart as we speak. And we can see this. We see galaxies being dragged away by space and time. We see the light from galaxies being redshifted. They're elongating. This is because the universe is stretching and light is stretching with the light. So we see all the galaxies being redshifted around us, meaning that the universe is expanding in all points. Think of a balloon that's just being blown up really quickly. That's how the universe is, and we're being dragged along with it. So if you can imagine the entire universe expanding, if we rewind the tape back, you go back to a smaller, hotter, denser initial condition, where the entire universe we know today, all the matter, all the galaxies, all the planets and stars, even you and me, all the matter that makes us up, was once compressed to a tiny volume the size of a grapefruit. And that state was exceedingly hot. The matter we know today wasn't even there yet. It was some kind of weird quark gluon plasma, a weird type of matter. So from that state, the universe rapidly inflated. And that's really what the Big Bang describes. Anything before that initial state, we don't know. However, there are some ideas. One of the best ideas, based on the best available evidence, is eternal inflation. It involves quantum mechanics. But don't worry, I'll make it simple for you. Imagine a little volume of space and time, empty space. It's a vacuum, there's no particles in there, it's just empty space. Well, quantum mechanics shows us that even in the emptiest of empty spaces, there's still energy, there's still potential energy fluctuating in this quantum vacuum. So it turns out these are called inflaton fields, and we can describe these inflaton fields as potential energy wave functions. In other words, the energy states in these fields can fluctuate, they can change over time. That's just a random nature of quantum mechanics. These things can fluctuate randomly. Now, there's one particular state at a plateau or peak called a false vacuum state. And naturally, things at their peak states want to go down to a lower state, and this is what happens over time. It goes from a false vacuum and it slowly rolls down into a true vacuum state. But going from that high state to that low state in a slow fashion, that process can precipitate things like inflaton particles. This is like baryonic matter, like quarks and gluons, very tiny subatomic particles, the fundamental ingredients of what makes us up. So from that empty space, there's still energy there, fluctuating, and certain fluctuations can yield inflaton particles. And it turns out that this particular fluctuation causes the inflaton field to inflate rapidly, super rapidly. So from this inflaton field that fluctuates, we can get that quark gluon plasma that I was talking about before, the stuff that the Big Bang talks about. And as the universe inflates after that, it gets colder. As the volume increases, the average temperature decreases. So the universe inflates, it gets colder, and atoms form. Nuclei form, atoms, helium, hydrogen, the building blocks of stars. Then stars form. As the universe inflates even more, it gets colder, stars form. They undergo nuclear fusion, they produce elements, heavier elements, the stuff we're made of, like carbon and oxygen. Stars, and then galaxies. And then that gravitational force caused by that dark matter in those galaxies slow down the inflation. They slow down the expansion a little bit. But the universe still inflates. The more it inflates, the more it thins out. The vacuum energy takes a hold again, continues to expand further and further. And that's really where we are today, about 14 billion years after that initial rapid inflation. So that is the whole picture in very simple terms. Now, what's the evidence of eternal inflation? Well, there's two things. We have the CMB radiation that we see. This is a map of the entire universe in terms of microwave energy. Now, this energy seems to be homogeneous throughout the universe. It seems very uniform. And for many years, scientists could not explain why the universe seems to be so uniform. I mean, 360 degrees all around us. Why? Well, it was because that small volume of space and time rapidly expanded so fast that the initial configuration of matter was preserved because it expanded so quickly that it was preserved. The uniformity was conserved as it inflated. It also explains the fact that the universe is flat. Scientists didn't really know why the universe was flat, but eternal inflation explains why the universe is flat. Because the initial conditions, it was curved. As it inflated rapidly, it flattened out. So these models combined paint a very good picture of the universe we see. Now, of course, there are flaws in this, and we don't know every piece to the puzzle, but we have a good general idea as to what's happening. And that initial space and time could be fundamental. It could be that there's a fundamental layer of space and time that just grounds everything. And big bangs happen all the time in different inflaton fields. They expand, they inflate rapidly. Other big bangs occur all the time around us. We don't know, but all we know is that we are in this one universe. And I'm tired of hearing people say that, oh, because we're in this universe, it's so perfect, how can this come from a big explosion? It must be God. Well, either way, our existence is explained, whether from God or from natural processes or quantum fluctuation. Our existence is mind-boggling in itself. The fact that we exist today, whether or not it's from God or physical processes, it's amazing that we're here today. It's mind-boggling either way. So don't use the counterintuitiveness or your ignorance on how the world actually operates as good reason to inject your God into the picture. Because as the more we learn about the world around us, the more crazy it becomes, the more counterintuitive it becomes. The universe isn't obligated to make sense to us. It just seems to be.
A lot of times I watch videos like this and I think to myself, like, who came up with these theories? Like, who figured out the Big Bang? And a lot of the times we might not even be right. Wasn't it like in the 1500s where they were like, oh yeah, the Earth is the center of the universe, and then now we're like, nah, it's not real.
Let's talk about what could potentially be beyond the observable universe. So the first theory is that there is a void, or a whole bunch of nothingness. It's possible that outside our universe there is absolutely nothing. We've seen these empty spaces in our own universe, and they are filled with what we call dark matter, which is just an invisible gravitational force that sort of keeps things in position. While studying a cluster of galaxies, scientists noticed that they were all moving in a similar direction in the universe at about 2,000 miles per hour. This is when they created the theory known as dark flow. Imagine something similar to a black hole, except much stronger and much bigger than our entire universe. Now, some researchers believe that the universe is actually just a big sphere, and that no matter how much you try and get outside of it, you will always end up going around it, so you will end back at the same place where you started. And finally, we have the multiverse theory. So basically, like setting up multiple mirrors in front of each other and seeing a never-ending reflection of itself, these multiverses are exact copies of our own.
This is so crazy to me. There's actually scientific proof that humans are not physical beings, and that in fact, nothing in our universe is physical or solid. This is a picture of a quark. So quantum physics tells us that everything is fundamentally made up of atoms. Everything in our universe is made up of atoms that are made up of electrons, neutrons, and protons. And protons and neutrons are made up of quarks. And electrons are made up of leptons. But what are quarks and leptons made of? They're made of nothing. Quarks and leptons are just pure energy. Quarks and leptons are fast-moving points of pure energy. They're made up of literally nothing. They are nothing. So that means that at the fundamental core of the atom, and therefore at the fundamental core of everything in our universe, there is no material there. It's just pure energy. It's energy vortices. You are just energy vortices. Energy is only transformed. It's neither created nor destroyed. So this energy that is you and that is everything persists forever. It is immortal. So this means that you're not just a temporary flesh sack that lives for 80 years, then dies forever. You are the same energy as everything in our universe. So this means that humans are purely eternal spiritual beings, and that the physicality and solidity of everything is just an illusion. You are an immortal divine being, and next time you feel alone, just know that you can't be alone, because you literally are one with everything, because you are everything.
Does it bother me to know that there's something massive outside the observable universe, and we can't see it? And also, what do I think it is? First of all, not knowing is a delightful state to be in, because that's what feeds your curiosity. You can't walk around saying, I don't know something and upset by it. You gotta walk around saying, I don't know this and I want to find out. That's how it should unfold for all of us. And what do I think it is? I have no idea. There it is. Welcome to the state of mind of a scientist on the frontier, standing at the boundary between what is known and unknown, and peering out into the abyss of ignorance. I love it.
What if I told you the universe is only here because you exist to observe it? So this book right here is the Anthropic Cosmological Principle, written by Frank Tipler, who is a mathematical physicist, and John Barrow, who is a physicist and cosmologist. This book sets out to explore one of the deepest questions in cosmology. Why is the universe seemingly so perfectly fine-tuned for life? They speak to the strength of gravity. If it was slightly stronger, stars would burn out too quickly and collapse before life could be formed. Slightly weaker and stars wouldn't form properly, meaning no planets, no complex chemistry, no life being formed. If there was a tiny variance in electromagnetism, life could not be created. The same with strong nuclear force, the same with weak nuclear force. The ratio of electrons to proton mass, the balance between matter and antimatter, cosmological constant, which is the constant that controls the expansion of the universe. If any of these were even slightly off, life would not exist. So back to the question, why does the universe seem so perfectly tuned for life? First option is the weak anthropic principle, or WAP, W-A-P. WAP simply states that the universe allows for observers, otherwise we wouldn't be here to observe it. It's not hard for you to understand that you live on a planet that allows for life, because if you didn't, you wouldn't exist. Out of all the possible universes that you could exist in, you exist in the one where life could emerge, because otherwise you wouldn't exist. The next one is the SOP, the strong anthropic principle. The universe was not randomly suitable, but it was bound to be this way. In religion, people would say God created this so that we could exist. In other interpretations, it's just simply that the universe is so precisely constructed that life was inevitable to emerge. And they propose a third in their book, which is called the FAP, the final anthropic principle. Not to be confused with NoFap, but FAP simply states that once intelligent life emerges, it can never be fully extinguished. It can never fully die out. In fact, that intelligent life will take control of its cosmic evolution, which potentially leads to a future where intelligence actually begins to shape the universe itself. It's a really fascinating book that connects physics, philosophy, and even esoteric ideas about consciousness, reality, the constructs that we live within. Key takeaways: that the universe is precisely designed for life, like so precisely that it is not logical to think that it came about by accident, right? Occam's razor. 2, observers are necessary for creation to exist. The observer collapses into reality, creation. And 3, the final destiny of intelligence could be to take control of cosmic evolution. And it's 3. It 100% is 3. All the friction, all the chaos that's going on, that's just the contractions before birth. That's just the friction within the cocoon before the emergence. Ask yourself, if the earth is a womb, and if this chaos, this friction you're feeling is the push and pull that is necessary for birth, what is being birthed?
There is a terrifying theory about our universe that the human mind can't comprehend. It's called the eternal universe theory. Many astrophysicists wonder if the Big Bang was merely an event, and not when the universe actually formed, but instead, the theory suggests that the universe has always existed. In this view, the universe is seen as an unchanging and infinite entity, where matter and energy are continually being created to maintain a constant average density as the universe expands. Unlike the widely accepted Big Bang theory, which proposes that the universe originated from a singular point in an event known as the Big Bang, the eternal universe theory suggests that the universe has always existed and will continue to exist indefinitely. This idea challenges the conventional understanding of the cosmos and raises profound questions about the nature of time, space, and the ultimate fate of the universe. Supporters of the eternal universe theory argue that it provides a more elegant explanation for the universe's existence. By eliminating the need for a cosmic beginning, the theory avoids the conundrum of what preceded the Big Bang or what caused it to occur. It also negates the requirement for a hypothetical singularity, which is a point of infinite density, a concept that currently lies beyond the reach of our scientific understanding. Moreover, an eternal universe implies that the conservation of energy and matter holds true throughout time, reinforcing one of the fundamental principles of physics.
Universe? I really want this new thing. Wait! Why did you change everything? To make room. But I want the new thing and everything else. I want it to stay the same, but still get the new thing. Getting this requires you to grow to be eligible for it. In your case, you were being held back by all of these things. So I removed the things holding you back. I chose the safest path for you. But now things are too different. I want to go back. You want to go back to how things were? Yes. It's too scary here now. You can have the life that you used to have. You're allowed to settle or stop progressing whenever you want, but you'll relive the same experiences again and again and again until you integrate them. You'll fall back into your old patterns, be around the same people with the same mindsets that you've outgrown, relive the same feelings, feel the same fears, and be held back by the same apprehension forever. You won't grow or expand. Are you sure you want to go backwards? Well, now that you put it that way, no, I'm not. But I don't want to be here either. I'm just uncomfortable. Of course you are. You're in between two chapters of your life. You're releasing a lot in order to make room for bigger and better things. You're still on the right path, even if it feels uncomfortable right now. Just relax. You're exactly where you need to be.
The odds of you being born is 1 to 400 trillion. Scientists estimate that roughly 30 billion humans have lived throughout our existence. That means that the likelihood of you being alive at any period in human existence is a 1 in 15 million chance. What I'm trying to say is you were given this chance. You are the lucky one, the one that gets to live, the one that gets to love, the one that gets to grow. Your life is so much more valuable than you think. Don't throw it away.
Is it possible mathematically that our universe is on the other side of a black hole? And could there be more universes on the other sides of black holes?
That's a great question. If you fall in, your time slows down relative to what you just came from.
Right.
And you'll see the entire future history of the universe unfold.
Right.
As you go down and emerge, a whole other space-time opens up in front of you. But general relativity works in all these other ways. And this is a prediction of something that has worked so well.
Mm-hmm.
It's intriguing. The universe that has the most universes,
right,
is the universe that has the most black holes. The universe,
right,
this is beyond which you cannot see,
okay,
has all the same properties as the event horizon of a black hole.
That's actually crazy. That reminded me of Interstellar, like how they were using black holes to travel to other points in the universe. You get what I'm trying to say? So pretty much in Interstellar, what they were saying is like black holes work like this, right? I'm gonna get y'all right. So point here, point here. Can you even see that? So look, 2 points, right? Instead of going down like this, the black hole makes it faster and you just go through. I know, it's crazy. Definitely check out, if you guys haven't seen Interstellar, make sure to watch Interstellar, dude. If you haven't seen Interstellar, make sure to watch Interstellar. It's an amazing movie, one of my top 5.
Thank you all for watching this here video.